Okay, in this video we're going to be doing Calc BC Problem Set number 36. Problems and a playlist are in the description below. Let's take a look. Number 1, find the slope of the line tangent to the graph of the polar curve r equals theta cubed over 6 at theta equals pi over 6. I'm doing this by hand and it's a bad choice. Alright, so step 1 is we have to convert to x's and y's because slope of a tangent line is dy dx. So we need to use x equals r cosine, y equals r sine. I'm going to start with x equals r times cosine. So I know that I need to find dx d theta, so I'm just going to go ahead and do that in terms of r and theta instead of plugging in theta cubed over 6. I think it looks a little cleaner this way. I'm not sold on that, but I'm doing it anyway. So it's product rule, so dx d theta is going to be, so first, which is r, derivative of the second is negative sine of theta, plus second, which is cosine. Derivative of the first, I'm going to write just r prime, but it's dr d theta. Don't forget that. So r prime. So that's x and then dx d theta. We'll do the same thing with y. Y is r sine of theta, which means that dy d theta is going to be first, which is r, derivative of the second is cosine, plus second, which is sine. Derivative of the first, which I'm going to write as r prime, but remember that's dr d theta. So r prime. Okay. Now, I'm going to need to figure out values so that I can just sub into this thing. So r prime, we know is dr d theta. That's just power rule, right? So it's bring the 3 down, subtract 1, so you get 3 theta squared over 6. So theta squared over 2. So r prime of pi over 6 is just disgusting. And that's where this is kind of problematic. So we get pi squared over, I'm going to write it as 2 times 6 squared because I think we're going to have a ton of simplifications that we can do along the way. And then r of pi over 6, which we also need, is going to be pi cubed over 6 cubed times 6, so 6 to the 4th. All right, now we're looking for dy dx when theta is pi over 6. So that's what we're looking for. We have to make sure that at some point we say that dy dx is dy d theta divided by dx d theta, so let's get that out of the way. And then we're going to evaluate everything at pi over 6, but we know most of the value. We actually know all the values at this point, right? So we know that r is pi cubed over 6 to the 4th. We need the we need cosine of theta. Cosine of pi over 6 is root 3 over 2. And then plus the sine, which is 1/2. And then r prime is pi squared over 2 times 6 squared. All right, so that's dy d theta evaluated. Now dx d theta evaluated is going to be r, which is the pi cubed over 6 to the 4th, and then negative sine of pi over 6, so negative 1/2. I'm struggling here. Plus the cosine, which is root 3 over 2, and then r prime, which is pi squared over 2 times 6 squared. Doing this by hand is like a really bad idea. I don't think you'd be asked to do this on an AP exam. It's just too annoying, to be honest. But you need to know how to do it, so not a bad problem, just ugh. I'm going to multiply everything I see by 2 times 6 squared over pi squared over 2 times 6 squared over pi squared, right? So I'm kind of like semi-clearing denominators here. So I'm going to multiply the top and the bottom by this. That's going to leave us, after we simplify, with this. Now I'm going to multiply everything I see by 36 over 36, which is going to ultimately leave us with pi root 3 plus 18 over negative pi plus 18 root 3. That's the work. Would you be asked to do this on an AP exam? No. Might you be asked to do this in class? Definitely. So there you go. Let's take a look at the next part. If f prime is cosine of 2x cubed and f of 0 is 5, what are the first 3 non-zero terms of the Maclaurin series for f of x? So a Maclaurin series is centered at 0, which is why we're not being told to center here. Also, we were told f of 0, which means that's basically the only thing we have to work off of. So I'm going to start off, because cosine is involved, with just cosine of u. So cosine of u, cosine's an even function, so you're going to get all the even powers, the even factorials, and it alternates. So you start off with 1, and then you go minus u squared over 2 factorial plus u to the 4th over 4 factorial. That's 3 non-zero terms, so I'm going to stop there. Now, cosine of 2x cubed, replace every u that you see with 2x cubed. So we'll still have that 1, and then you're going to get, so you'll have 2 squared, and then x cubed squared is x to the 6th over 2 factorial, plus 2 to the 4th, x cubed to the 4th is x to the 12th over 4 factorial. All right, let's write f of x as an accumulation function, or basically, so f of x is approximately what we're starting with, which is 5, plus the integral from 0 to x of this cosine of 2, I'm going to say t cubed. I'm going to take everything, every x, and replace it with t in my cosine of 2x cubed. So that's going to give me the quantity 1. And then 2 to the second over 2 factorial is just 2. So 1, I'll have minus 2 t to the 6th. And then 2 to the 4th is 16 over 4 factorial is 24. So that's 2/3, so plus 2/3. T cubed, sorry, t to the 12th. Yeah, I was going to explain how we get that 12 again, but we already know. All right, so now we have to integrate this. It's just reversing the power rule. It's a definite integral, so you don't have to worry about a plus c situation. So our 5 is still there. So integrate 1, you're going to get t, and then sub in x, and sub in 0, you just get x. Plus 1 times the reciprocal, so negative 2/7. T to the 7th, plug in x, plug in 0, you just get x to the 7th. 2 over 39, right, because plus 1 times the reciprocal, and then x to the 13th. And then you look at this, and you're like, we only needed 3 non-zero terms. We've ended up with 4, so I'm just going to cross that out. We don't need it. So our answer here is this. That's how you want to accomplish these problems. Like, use the series that you memorize, sine, cosine, e to the x, 1 over 1 minus x. Write your series, then multiply by whatever you need to, get your answer. You can integrate it, you can take a derivative. All right, let's take a look at the next one. This one's calculator because the calculations are super annoying. The temperature of a surface in degrees Celsius is given by C of t, which is shown above. What is the average temperature of the surface on the time interval from 4 to 7? Throwing this in here because I don't ever want you to get these wrong. We're looking for the average temperature. We have the temperature. That's going to be the integral divided by the interval, and that's all there is to it. So the integral is from 4 to 7 of C of t dt. The interval is going to be 7 minus 4. That's approximately. So here's a calculator shot of what I typed in, but I literally just typed in that integral. So we get 72.339 degrees Celsius. So that one's like really quick review, but still is a very important idea. Let's take a look at the next one. So this one is disgusting. And I don't know, it ended up like way harder than I thought it was going to be. And I'm pretty confident of the answer, but if you get something different, let me know, and let me know where you think I went wrong. A portion of the graph of g prime is shown above. If g of 1 is 3, write the second degree Taylor polynomial to h of x, which is g of x at x equals 1. We know that g prime continues linearly between 4 and 10, so we just continue that line the way that it is. Actually, I probably should have said that it like is just linear from 2 to 10. Maybe that would have been clearer, but we're continuing the line. That's the intention of the problem, so don't take issue with that. All right, we're going to need the value of the function, the value of the first derivative, the value of the second derivative. Then we'll just write our polynomial. So finding those values, that's going to be the tough part. H of 1 is going to be g of 1, which doesn't seem bad. G of 1 we know is 3, so it's just g of 3. To find g of 3, we're going to have to do an accumulation function because we know g of 1 is 3 and we know g prime. So g of 3 is going to be g of 1 plus the integral from 1 to 3 of g prime of t dt. So this is going to involve 2 trapezoids, which is phenomenal. So 3 plus the integral from 1 to 3 of g prime of t dt. All right, let's break this up. So we're going to go 1 to 2 and then 2 to 3. So from 1 to 2, I'm going to call A, and then 2 to 3, I'm going to call B. A is going to be 1/2. The height is 1 because you're going from 1 to 2. The first base is 3/2. The second, the first base is 3/2. The second base is 2. So that overall gives you 7/4. For B, it's basically the same idea. It's trapezoid, so it's 1/2. The height is 1. The first base is 2. The second base is just 1/2. Overall, we're getting 5/4. So a lot of geometry here. So we're doing 3, and then plus the quantity 7/4 plus 5/4, which is 12/4, which is 3. So 3 plus 3, 6. We now know h of 1. We need to find h prime and h double prime. So h prime is going to be So it's g prime of g of x times g prime of x, right? The derivative of something is g prime of that thing times the derivative of that thing. That's what we've done there. So for h prime of 1, it'll be g prime of g of 1 times g prime of 1. So this is actually easy, or I don't know about easy, but so g prime of 3, because g of 1 is 3, and then g prime of 1. This is the graph of g prime that we're looking at. So g prime of 3 is the y value at 3, which is definitely 1/2. And then g prime of 1 is the y value at 1, which is 3/2. So we're given the graph of g prime. You always have to like reflect back on that and remember that. All right, so we know that. So we know h of 1, h prime of 1. We need h double prime of 1. H double prime of x is, so it's going to be the derivative. So we need to use up. So remember, h prime is g prime of g of x times g prime of x. So we're using the product rule. Within the product rule, we're going to have to use the chain rule and whatever is called for. So it's first, so g prime of g of x. Derivative of the second is g double prime of x. Plus second, which is g prime of x. Derivative of the first. So the derivative of g prime of something is g double prime of that thing times the derivative of that thing, which is going to be g prime of x. Okay, now we just need to find h double prime of 1. And so that's going to be g prime of g of 1 is 3. So 3, g double prime of 1, g prime of 1, g double prime of g of 1 is 3, so g double prime of 3, and then g prime of 1. All right, so as long as we can fill in these values correctly, we should be good. So g prime of 3 is going to be 1/2. G double prime of 1 is the slope of the graph that we're looking at 1, which is up 1 over 2, so 1/2, plus g prime of 1 is the value of the graph at 1, which is 3/2. G double prime of 3 is the slope of the graph at 3, which is down 3 over 2. And then g prime of 1 is the value of the graph again, right, which is 3/2. Okay, we get 1/4 minus 27/8. That's 2/8 minus 27/8, negative 25/8. Okay, so now what we have to do is we just have to put this into the formula. This is kind of an annoying problem. So h of x is approximately the value of the function, which is 6, plus first derivative, x minus 1 to the first over 1 factorial, plus second derivative, which is negative 25/8, x minus 1 to the second over 2 factorial. That's our approximation. That's the entire problem. Okay, that's the problem set. I hope this was helpful, and good luck.